Hi, my name is Jed Shirey, and I'm going to be walking you through the design of a small-scale biodiesel production system. This PowerPoint here is the result of 2 semesters of work by the Systems Engineering group at George Mason University. This is the capstone project for the Systems Engineering course there. We investigated the Fredericksburg area of Virginia, particularly Spotsylvania and Stafford counties, and the farms in this area. U.S. agriculture census shows that farmers in this area have suffered decreasing profits since 1997. This is primarily due to an increase in farm production expenses. Farm production expenses have increased 164% from 1997 to 2007, and a lot of this can be attributed to the rise in fuel-dependent categories. The chart here shows the increase in diesel prices for the Central Atlantic region, which includes Fredericksburg, Virginia, and shows that there's been a 230% increase in the price of diesel since 1997. And all these numbers and percentages are inflation adjusted. An alternative to buying diesel from a gas station is to produce biodiesel on the farm. The way this works is you plant a crop, such as corn, and when you harvest the crop, you crush the corn to get vegetable oil out of it, and then run this through a biodiesel processor, which converts it to biodiesel. Some of the benefits of this is that it can be used in existing diesel engines. There's no need for modification. So our conclusion, based on our original research, is that there is a need for a small-scale biodiesel generation system for farms located in Fredericksburg, Virginia, and this will help them to decrease their operating expenses and possibly even have a new product that they'll be able to sell. We chose to focus on various crops that could be used to produce vegetable oil, and so we investigated a number of different alternatives and settled on 5 basic ones to evaluate. We constructed a Monte Carlo simulation to evaluate these to determine which was the best option. So our objective was twofold, based on 2 parts of the model. We wanted to be able to determine the biodiesel yield and the net energy ratio of each of the 5 crop alternatives, and then we wanted to determine the net present value of each crop alternative at the end of the system lifespan, which we assumed to be 15 years. Based on that, we can plot the utility of each alternative versus the net present value and present stakeholder with the various information to make a decision as to whether they want a high utility alternative or perhaps settle on one with more profit. The design of our simulation, this is the first part, the biodiesel production. It accounts for the crop yield and the vegetable oil yield. These are random variables based on historical data, and we used various equations to determine the biodiesel yield as well as the glycerin and meal yield, which are profitable byproducts of the process. These in turn flow into the business simulation, which calculates all the costs associated with biodiesel production. Again, you can see the random variable inputs across the top. Primary inputs there is the planting and harvesting cost. So on a farm, you have to get the crops, you have to plant it, go through the full season, fertilization and such, and then harvest them, and that's a major cost in biodiesel production. We did this for 3 different scenarios, using 10 acres of farmland, 15 acres, and 20 acres. And the output of this is the net present value. So basically this allows us to determine how much biodiesel each crop is likely to produce, as well as the cost associated with that run out through 15 years. For actual implementation, we used Crystal Ball and Excel add-in to do our simulation. We did 50,000 iterations for each simulation, and we assumed that there were 75 acres of farmland. This shows some of the results of the first model, particularly the biodiesel yield. Based on our calculations, it shows that the peanut, you can expect about 136 gallons of biodiesel per acre. Corn is at the opposite end, low end of about 19 gallons of biodiesel per acre. You see the standard deviation there as well. The net energy ratio is shown here. To make biodiesel production viable, the net energy ratio should really be above 1. As you can see here, all the alternatives except for corn have a high probability of their net energy ratio over 1. Another important factor from the business simulation is the cost per gallon. Canola has a very low cost per gallon in terms of production, 69 cents. Corn you'll see is negative, which actually means that they gain money by producing biodiesel. That's because of the high meal output that can be sold as a byproduct. This chart shows the probability of the net present value being greater than 0 for the 3 different scenarios. Just to highlight canola, you'll see that it has a 0.14 probability of being greater than 0 when you're using 10 acres of biodiesel. However, it increased to a 0.9 probability when you're using 15 acres for biodiesel production. This is primarily because of the low cost associated with canola production, and so the more you produce, the more you're able to sell for a profit. The sunflower, peanut, and soybean have a very low probability of positive net present value for all the various scenarios. This is due to the high production costs, and even though you have lots of extra biodiesel to sell, you're not actually able to make up for the loss, particularly the initial investment for the machinery. This graph shows the net present value for the mean net present value at 10 acres for all of the alternatives. As you can see, corn has the highest and achieves a positive return on investment within 5 years. At 15 acres, both corn and canola have positive return on investment within 3 and 5 years respectively. And as you see across the bottom there, the peanut, soybean, and sunflower do not achieve a positive return on investment. This is for 20 acres. Again, canola and corn are positive. Sunflower will eventually reach a positive net present value in a very long time, so it's not a very profitable investment. Based on discussions with our stakeholder, we came up with the following value hierarchy to determine the utility or the various discriminators that can be used for determining the best crop alternative. Primary one is biodiesel yield at 0.5, weight of 0.5. Plant disease and production hazards are also important factors. Production hazards are actually not a real discriminator because all of the crops have effectively the same amount of hazard associated with them, but we included this for completeness. Based on this, we plotted the utility of each crop alternative versus the net present value. There are 3 points for each crop alternative representing the mean, 10%, and the 90% likelihood of achieving that output. You see at the top left, peanut has very high utility, actually of 1, but it has a mean and 10 and 90% probability of having a negative net present value. Corn across the bottom has lowest utility, but a very positive net present value. Canola sits right in the middle and has a positive net present value. As you see here, it's greater than 0. The best area is in the top right, so as points move closer to that, they have a high utility and also a positive net present value. Based on this chart, we recommend canola as the optimal crop type. It has a high biodiesel yield, which fits in with the needs of the farmer. It also has a positive return on investment. Even at the 10% probability, it's still greater than 0. And so at the end of 15 years, you're bound to have some money coming back onto it, so you're not just throwing money away. Corn is profitable, but has very low utility, does not provide very much biodiesel at all. Further research would need to be conducted to determine if the meal profits are indeed as high as we have calculated here. Sunflower has a small chance of earning money, but it's not very likely. And then peanut, of course, is very negative, very expensive to produce. So we recommend canola as the best crop type, and farmers implementing this with a high amount of acreage could make money off of this. Thank you.